Hi, Chris Kuzmal here. We're going to be describing how to implement a heap using an array list in Java. An array list, in order to be able to use it, we have to import java.util.arraylist. And then I'm going to show you what's in my main class, which is going to be the class with which I test my array list, with which I test my heap. I go ahead and have a hello world just for sentimental reasons, and on line 5, I create an array list of integers. I create two integer variables, pass and fail, that will count the number of passes and fails in my test cases. And then, for reasons that are specific to the implementation of a heap, I add a garbage value or a nonsense value of 99999. It's not really necessarily nonsense value, but intuitively speaking, that's sort of a value that's not we would not expect to use, even though in fact, of course, we could have a value in our heap of that size. We're going to then add a 0 and a 1 to the next two elements of the heap. And so at location 0 in the heap, I have 9999, or however many nines that was. At location 1, I have a 0, and at location 2, I have a 1. And that means, therefore, that at least when we are only considering starting at location 1, the values in my array list will be ordered in a way that conforms to the heap property. And therefore, if I call the isHeap method, which is a static method defined in the heap class, where I pass an array list, then it should indeed conform to the heap property. And if indeed isHeap says true, then our test passes, otherwise our test fails. But then if we add a -1 at location 3, then that's going to make it so that the array list no longer conforms to the heap property, and we would expect that if isHeap returns true, then that would represent a failure of our isHeap method to accurately perceive whether or not our our array list conforms to the heap property. And of course, otherwise we would pass. So ideally we will pass. And over here on the right, you see some things that I've run before, which included some printouts. And you see it passed twice and it failed 0 times. We'll run again and we will verify that indeed we passed twice and failed 0 times. Now then, the question is, what is in the heap class? So we go over to the heap class and see what's there. And the heap class only does a few things right now. We also here include an array list, and we define the class heap as being public. And we represent that inside of our heap, we're going to have a field whose name is A and whose type is an array list of anything that extends comparable. That's what inside the angle brackets, we have this declaration, which you do not typically learn in APCSA, and therefore I'm just pointing it out. So this involves some generic type, but what it means is that whatever we have here, question mark, extends comparable, and any method, any type that extends comparable can therefore be contained in A. Now then, to create a heap, all we do is we create an empty array list, which is of type comparable, and which contains elements which are of type comparable. And then the parent of a given element is just the index, that is, of the parent of a given element is going to be 1/2 of that element's index, and that's all that parent does. And left says that it indicates that the left child of an element in our heap is going to have an index that's twice of our index, and our right child is going to be 1 more than our left child's index. Those are all fairly straightforward, and now we use a subset. We use in particular the parent method to determine whether or not we satisfy the heap property. And so for any array list that extends comparable, that is any array list that could be a field in our class, we're going to first set to determine whether or not that conforms to the heap property, whether or not that is a heap at some sense. We first set our ret val to be true, and then we begin at index of 2 in our array list and proceed as long as that index is less than the size of the array list, incrementing that index by 1. And then the magic happens on line 28. It's not really that magical. We get the value at the location of the parent of the index and compare that to the value at our own index. And if the result of the compare to method is less than 0, then that means that that particular value value in that array list does indeed conform to the heap property because it is greater than the greater than its parent, or the value at that index is greater than that value at its parent. And we just iterate through all the elements for which it is legitimate to do so, and if all of them are true, which is what happens when we do the and equals, we're saying all of them have to be true, then we will get a true on our return. Otherwise, we won't. That's all we've implemented so far. A formal definition, or actually a implementation of the formal definition of whether or not we have a heap, along with definitions of how we implement the parent and left child and right child methods for the indices of an array list that implements a heap. Next time, we will start to actually work to maintain the heap property and perhaps build a little bit of an abstraction barrier in order to make it so we don't have to think as precisely about the indices and still deal with heaps successfully.